Question 2, which of these is a scalar quantity? So it only has a number or a magnitude. No direction, so acceleration, nope, that has a magnitude. Distance is a scalar quantity, but we'll check the rest. Force is a vector, weight is a vector, because weight is a force. So the answer is B, distance is a scalar quantity. Go on to the next one. A student's got some cupcake cases, that's that there. They're going to drop cupcake cases with the base facing downwards, and the speed depends on the number of cupcake cases. God, that's horrible. The student also has a stop clock and a meter ruler. Okay, now here's the crucial part. Describe an investigation. It's not asking you to say what you think the relationship is between these. It's describe what you would do to show how the speed depends on the number of cupcake cases. And we've got a stop clock and a meter ruler that we've got to talk about. So ultimately, we're going to raise the cases. Oh my God, that arrow is terrible. We're going to raise, I don't think that's any better. We're going to raise the cases to a height. We're then going to try a different number, making sure we've got at least 5+ results in the range. We're then going to time it as it falls down, and speed equals distance over time. And we're going to repeat it and work out a mean. So in terms of your model answer, measure a set height using a ruler, change the number of cases, for example, 1, 2, 3, 4, 5, 6 cases, time the fall with the stop clock, so we're always referring to what was in the question, speed equals distance divided by time, and we're going to repeat 3 times for each number of cases and calculate a mean. So the crucial part is read that question carefully. It's not asking you to say what the relationship is, it wants you to describe what you would do to find it out. Okay, so the next one is, we've got our My Wrinkly Gran. The stack of cases has that mass there, no unit change. Gravitational field strength is that, calculate the weight. And we can just use exactly what's got there. We don't need to rearrange that equation. So no unit changes, no rearrangement. Multiply that together. And there we go. Okay, the next one, figure 4 shows a cupcake case that's falling at a constant velocity. So that means that the forces are balanced. So draw an arrow to show air resistance. Well, air resistance is going to be equal and opposite. And that's because the forces are balanced. It's moving at constant speed. So an equal arrow upwards. The next part, state the value for the acceleration. Well, there is no acceleration. It's the forces are balanced, it's at a constant velocity. There is no acceleration, 0 meters per second squared. There we go, that's that one done.